Hey guys, we're going to continue here with chapter 8, section 5. We're going to start talking about something called dilations. And what you're going to learn today is to graph dilations and to determine the scale factor of a dilation. So let's go ahead and jump in here. Here's a couple vocab words. You need to write these down. A dilation is a transformation in which a figure and its image are similar. The ratio of a length in the image to corresponding length in the original figure is called a scaled factor. Dilations are when figures get smaller or they get bigger. So that's what we're going to be focusing on today for this particular one. So let's keep coming. I just want you guys to be aware that they are coming. People talk about the zombie apocalypse and all that. That's not nearly as scary as this. The statue apocalypse, it's already happening in some places, as you could tell by these photos that were caught and posted on various social media outlets. Okay, so finding a dilation. It says find the image of triangle ABC after a dilation with center A and a scale factor of 1/2. So what that means is I'm going to take this particular figure and I'm going to cut all these numbers in half. I'm centered around right here, point A. And so I'm just going to fill some things in. So for this, it's going to be half of that, which is going to be right about here. And for 12, it's going to be half of AB, which is going to be right about here. Now, if you had a ruler, you could actually figure that out. And then A is going to stay put. So this right here is my new figure. Now, because it has a, go ahead and label it A prime, and we'll call that C prime. This one we'll call B prime. Because it's a scale factor of 1/2, I could figure out the values of all these. So if this whole length is 16, and it's 1/2 a scale factor, that means this has to be 8, this has to be 6, and this has to be 4. So that's how you draw the figure on it. Make sure that you've copied this whole thing down into your notes and that you are writing out good examples. Here is one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. It's a center of D, so everything doubles in length. So this one went down 3, so it goes down 3 more, because this is 2 times that length. This one over 3, so this goes over 6. All right, this you could kind of figure out. You'd say, well, it goes down. This would be a radical 2, so it actually is some upper level geometry here. But this goes down, if you think of it as 3 diagonals, then I need to go down 1, 2, 3 more diagonals to double its length. All right, so hopefully you got that. If not, go back and try to find your mistakes. Let's keep moving here. So graphing dilation images. It says find the coordinates of the vertices of the image of quadrilateral KLMN after a dilation with a scale factor of 3/2, then graph it. Anytime you are given a scale factor with ordered pairs, what you're going to do is you're going to take each one of them and multiply their ordered pair by that. So K, see, is -4, -1. And so to find K prime, I multiply both of these by 3/2. So -4 times 3/2 is going to be -6. And then -1 times 3/2 is -3/2. And I'm going to go through and do this with each one of my ordered pairs. So L is -2, 1. When I multiply L by 3/2, I get, I get -3 and +3/2. Then I come here and I do M, and its ordered pair is 1, 1, which means M prime is 3/2, 3/2. And then my last one here is N, which is 1, -1, which means N prime is going to be 3/2, comma, -3/2. And then I just go through and I plot all of these ordered pairs, and that will give me that dilation of 3.5. So K is, let's see, -6 and -3/2. So let me change colors here. Dark blue. So -6 and then there. So that's going to be K prime. L prime is -3. So 1, 2, 3 and +3/2. So that's going to be here. M prime is over 1.5, up 1.5, so it's going to be right here. And then N prime is 3.5, down 3.5. So it's going to be here. Now when I connect all these points, what you should notice is that this figure looks similar to the original IKLMN. Same shape, different size. That's what we're talking about when I say similar. So if you use a ruler, it should come out a little bit straighter, but that's all you do with this. If you're given the scale factor, just multiply all the coordinates by that particular value. So here's one for you to try. The answer will be up in 3, 2, 1. All right, so here is what I got for all my ordered pairs, and then here you could see the new image that you draw. So hopefully you got that. If not, go back, try to find your mistakes. Let's keep moving. Here's an application that says TRSV shows the outline of a park. A city planner dilates the figure to show the area of the park that can be used for concerts. What is the scale factor in the dilation? So in order to do this, what we need to do is identify a couple sides that we can find their length. So I see a couple here. This one right here I could find, that's a 4 and then 4, so that's a length of 8. And then this one is 2. Right? So how do I find my scale factor? Well, I'm going to put the image on top. All right? In other words, T prime to R prime over T to R, which is going to equal 2 over 8, which simplifies to 1/4. That's all you're doing on that. That is the scale factor of the dilation. So if I'm going larger to smaller, it's going to be a fraction. It has to be less than 1. If I'm going smaller to larger, then it's got to be larger than 1. So it's got to, be that kind of number. So just use some common sense here when you're thinking about, is it going to be a number greater than 1 or less than 1? Which, by the way, a scale factor of 1 doesn't change the image. It's the exact same size. Here's one for you to try. The answer will be up in 3, 2, 1. All right, here's what I got. I found a scale factor of 3. This whole length right here is 6 plus 3, so be careful with that. And then that is an enlargement because it says the blue figure is the dilation image of the black figure, which means you start with the black figure. Blue is the image, so I get bigger in that case. That's it for today. Kind of a short lesson. That's nice. So make sure you've taken good notes. I will see you all in class.